Hello everybody. Today I'm going to introduce to you the method of partial integration. It is used for functions consisting of a product of two non-constant factors. This is the formula to use. U and V are placeholders for the factors in your product. Take a look at the integral on the right, this one over here. This is the integral you will be left with after having done the partial integration process. You see U dash and V. Key is now to assign your factors to the correct placeholders. For example, we have here this function x times cosine x, consisting of two factors, x and cosine x. And again, key is now to assign your factors, these two, the correct placeholders, V or U. U dash is the differential of U. So you want to choose the factor to be U, which eventually becomes 1 after differentiation. If you choose it correctly, the remaining integral will just consist of V, which should be easy to handle. You see, U dash and V is your new integral. And if U dash, for example, is 1, you are just left with an integral where V is part of. So I always write it in the following way. I first identify which factor in this integral is differentiated. So you have the differentiation of U. So I assign U x, because if I differentiate x, I will be left with 1, and this is the exact thing I want. So I write it the following way. I write U is x, U dash is 1. And now if you take a look, this is your integral, okay? This has to be the function you put in, okay? You said U is your x, okay? You got the U. So now you're looking for V dash, okay? The second factor, this is your V dash, okay? So we write V dash is cosine of x. Now you integrate V dash because you need V. And the integral of cosine x is sin x. Okay, again, you have x and cosine x at the factors of your product. You decided x to be your U because U dash is 1. And that's exactly what you want in this integral on the right side. So as a consequence, for U to be x, V dash is cosine x. Okay? You have these two factors, U and V dash. You said U is your x. So as a consequence, V dash is cosine x. So if V dash is cosine x, you need to integrate V dash to become V. And the integral of cosine x is sine x. Okay, and now we write x cosine x dx is the same. Now we said U is our x. V is sine x minus the integral. U dash is 1. and v is sine x. Okay? So that's what we did. We assigned u is x, u dash is 1, because we want to achieve that this u dash becomes 1. Because then the integral gets very easy. You see, this integral just consists of sine x. In these parentheses, we have u multiplied by v. U multiplied by v is x sine x minus u dash is 1 and v is sine x. And this integral you can solve. Now we have, put this way, yes, x sine x minus. Now you need to find the integral of sine x. And this is minus cosine of x plus c, because we're looking for an indefinite integral. Now you just simplify. X sine x dx is x sine x plus cosine x plus c. This is your result. So to check this result, it's very easy. We just have to differentiate this function. So we got x times sin x. The differentiation of it is sine x plus cosine x minus sine x. And you see, sin x minus sine x is 0, and you're left with x cosine x, which is exactly what we started with. So this is our result, and you see the integration was successful. Okay, so I'll give you another example, just so you can get a little bit more familiar with the notations. Okay, first was x cosine x. We can go now for x sinus sine x. Okay, so it's the same. The method is always the same. You look for the factor which when you differentiate it once or more times, eventually becomes 1. You have x, you have sine x. You know, okay, obviously this factor is x again. So you say, okay, u is x, u dash is 1, and the other factor, v dash, is sine x, and v is minus cosine of x. Now again, you just can, with this information you put in, you're now able to put in this information into this formula. So you have the integral of x sine x dx is equal to u times v, or u multiplied by v, is minus x cosine x minus the integral of u dash times v. U dash is 1, times minus cosine x dx. Now you see minus x cosine x. Now the integral of is the same as cosine x dx. Oops, your integral x sine x dx is equal to minus x cosine x. So the integral of cosine x is minus sine x. So this is minus x cosine x plus sinus x plus c. Now you can test if that was successful by differentiating this function, and this should be left with x times sine x after differentiation. Okay, so we do that. We have minus cos x plus x sin x plus cosine x. And you see, disappears. And that's x sine x. Yes. Now we go for an example a little bit more complicated. In the first two cases, we had a function where this x just had the factor 1, or the potence 1 x. Okay, so we had to go through the process of partial integration just once. But you can also use the method to go for functions where the factor of this x is not, or the potence of this x is not 1 but 2 or 3 or 4. It becomes very complicated, but I will show you how it looks if the factor is 2, for example. You have the function x squared cosine x. All right, so we're going to do the factor which disappears after multiple differentiations, or not disappears but becomes 1 after multiple differentiations, is again this x. So we choose u is x squared, u dash is 2x, v dash is cosine x, and v is sine x. All right, and now we just start by writing out square cosine x dx is equal to, we put in u is x squared, v is sine x. Put that there. So you have x squared sine x minus the integral of u dash, which is 2x times v, and v is sine x dx. All right, so now you see this integral. Okay, take a look at this integral. The factor of this x reduced by 1 compared to this x. So you have still two factors, x and sine x. So you have to go through this process one more time to reduce the potence of this x one more time. Okay, to become 0, so this factor will become 1 and you just be left with one term with v in there. Okay, so first I'm going to copy this. Simplify it a little bit. You can put this 2, you can write in front of the integral. X sine x dx. Okay, and now this factor just stays untouched. We ignore it for once. We just focus on this integral. For this integral, we are going to apply partial integration one more time. So integral x sine x dx. So you have u is x, u dash is 1, v dash is sine x, and v is minus cosine of x. So now we can write it. Put it in there. Okay. So minus 2 times. And now we go through this formula again. Okay. So we are now left with, we have u times v, u times v is minus x cosine x, okay, minus the integral of u dash is 1 multiplied by v, this is minus cosine x dx. Okay, I have integral x squared cosine x dx is equal to x squared sine x minus 2 times the integral minus x cosine x minus, now you need to plus this minus, we can multiply it with this minus and it becomes a plus, and the integral of cosine is sine, because if you differentiate sine, it will become just cosine, and the minus we just put in front of the integral and it becomes a plus. Okay, so we have x squared cos x dx is equal to x squared sine x minus plus 2 times x cos x minus 2 sin x, x plus c. Okay, this should be our final result. We check if it's true by differentiating it. So x should be x. We do that. So we got first this term. We got 2x sine x plus x squared cosine x plus 2 cosine x minus 2x sine x plus 2 minus 2 cosine x. And now we see 2 cosine x disappears, 2x sin x disappeared with this 2x sin x, and we are left with is equal to x squared cosine x, which is our function we started. So we have the confirmation that we integrated the right way. Yeah. I hope you took something out of it. I'm sorry for my English to be not that awesome, and I hope it's taken something out of it and you're not afraid of the partial integration anymore. In the next days or a couple of weeks, I will make a video about the integration by substitution. This is one of my favorite ones because it's a very, very elegant way to integrate functions which on the first glance look very complicated, and then they simplify quite heavily if you know what to look for.